Yeah, welcome back to our new session. So this is the second session that we are conducting. So today we will be mostly discussing about the containerization. Means we had a discussion on containerization, Docker, and all in the previous session, and also as well as we had a lab as well. So today we will be discussing more on Kubernetes, which is completely a containerization topic. Today we will be discussing mostly on Kubernetes. Okay, Kubernetes. Yeah. Before that, we will be discussing some more things also. But our main agenda is to cover Kubernetes, the concepts and all. Hmm? So basically, just wanted to know whether are you aware of Kubernetes? We heard about it.
Sir, isn't it Kubernetes and Dockers like both are the containers, but Docker is on the base level and Kubernetes is for the advanced level. Is it kind of similar?
Uh, as we know, containerization is the technology that we are following, right? Containers, we will be talking all the time. So how we created a container in the last session, we understand that we will create a Docker image, right? We will create a Docker image with the help of Docker file, and it will create Docker containers, correct? So let's see if we have 1,000 Docker files. Okay. Mostly we may have at least 1,000 Docker images, right? Similarly, we will have at least 1,000 containers. And yeah, we will get an option. We will have an option to provision versions, right? Like we did :1, :2, like that. So we can have different versions as well. So at least we will have 1,000 or more containers we will have. So there will be a huge headache how we can manage. So in that scenario, actually, Kubernetes will help us. Okay. Kubernetes is mainly for, yeah, it will help us to deploy. It will basically Kubernetes. Yeah, I'll come to Kubernetes. So this is the requirement of Kubernetes actually, because we will have different Docker files for different applications and all. Maybe in one Docker file we'll be deploying, like referencing some things, and we have a lot of Docker images in place. From that, we are like provisioning different containers with the different versions, which means a lot of containers we have and a lot of applications we are running, and it's very like overhead task. It will be very headache for those administrators to handle all those containers, right? Because we can easily manage if it is 1 or 2 or 3 or 10, up to 10, or right. But if it is more than 100 or more than 1,000, let's say there are some services like in the like Netflix. There are a lot of tools available now, like Netflix and all. So they have like more than 10,000 containers. So how they, or 5,000, or yeah, I'm just taking an example. A lot of containers. So how we can manage? How can we manage it? Because otherwise it will be a huge headache. Because all of them we need to manage. All of make sure that it is up and running. Application is not going down like that. A lot of steps we need to take care now. So in that case, actually, Kubernetes comes in. Kubernetes is something like an orchestrator. Okay. So we can call it as an orchestration tool. Okay, we also call it as K8s. Okay, K8s. Kubernetes K8s. Everything is similar. Okay. So do you understand the requirement of Kubernetes?
Yeah, yes, sir. I mean, the purpose would be the same for Docker and Kubernetes, but Docker is for the less scale, and Kubernetes are for the large scales. I mean, it's more flexible for the large scales.
Yeah. Both comes under containerization technology, but in Docker, what happens is using a Docker file, we will be creating an image and then we will be creating a container. In Kubernetes, we will have one file similar like Docker file, but it is something different. We can call it as a YAML file. Okay, and it is something like a HTML file. Okay, it's a simple, easy to understand. So with the help of that, we will describe all those things over here. So it will deploy containers. Okay, it's a method of provisioning containers, managing, deploy, scaling up, scaling down. Yeah, all those things can be taken care. So same as part of Docker file, we will have a file. In that file, we will mention, okay, what all containers need to be created, what all kind of things that we need, what all properties we need. All those kinds of things we will be mentioning inside this YAML file. And accordingly, once we build it, here what we did, we build, right? We build the Docker file and then we got a Docker image. Once we have this Docker image, we did what? We actually will run, right? Then we got containers. So like similarly, here we have a YAML file in place. So with the help of that, once we run that YAML file, we'll get containers. Okay, so the idea is like same as containers, but it is like managing, mainly how can manage, how we can do their upgrades or scaling, a lot of things. So Kubernetes will help us to manage it easily. That's what the exact requirement of Kubernetes. So we'll call it as K8 as well. Okay, sounds good.
Okay.
Okay, and yeah, I'll come to some more part. So we already discussed that there is some infrastructure that we will be following in the olden times. Yeah, I'll repeat that once again so that it will be easy to understand. So we told, like in there, let's say we have different kind of deployments. I'm taking traditional deployment. Okay, we already discussed it in the last session, but for clarity and for a better understanding, I'm saying that once again. So in traditional deployment, what it is happening here, we will have a hardware. Okay, hardware or a server, we can call it like that. So we will have a hardware. In that hardware means CPU or something. Okay, a server. In that, what we will do, we will install an operating system, right? We will install an operating system. Either it is a Windows or Linux or whatever it is. And what we are doing, we are installing or we are like provisioning some applications in this. So this was the traditional deployment. And in traditional deployment, actually what happens? So mainly this could be a physical server. We can call it as a physical server. Okay. So this physical server will be there. And the main thing is there is no boundaries for applications. Okay. There is no boundaries. in physical server. So if we have an operating system available, multiple applications may be provisioned, and there is no boundaries or something in between these applications. And what happens? This app 1, app 2, app 3. Okay. These applications may face issues in terms of resource allocation. For example, if I'm saying, yeah, here we have 3 applications now. So let's consider 3 applications are running on a physical server. So there may be instance where this application app 1 need more resources. Okay, which need more resources. And what happens? App 2 and app 3 would underperform, right? So a solution for this would be like to run each application on different servers, right? Because either app 1 or app 2 or app 3, anyone will be mostly utilizing most of the resources of this hardware is this of the server, and the others go underperform. So we will come to a situations that we need to buy extra hardware for app 1 and app 2, like that, right? So it will be basically like expensive for organizations, because we need to maintain different physical servers for different applications. And also it's very hard to scale up, right? Because if we need to increase the in terms of compute or something, like they need to trade in some more from the market. So this is what traditional deployment was. So I'm just explaining this for a more clarity. Do you got this?
Yeah, yes, sir. To be personalized virtual machines, I mean the servers for the specific applications.
Yeah, definitely. It's like that. So
yeah, and eventually it would cost us like it would be more expensive.
yeah, because we need to buy a new hardware like that, no? Because the
Yeah.
issue is like we can't judge how these applications will behave. Maybe app 2 may need a lot of resources than app 1 and app 3, then it will like outperform the other application. So we may face issues with app 1 and app 3. So we may think about to provision this application in a separate server or something. Then they need to buy it, procure it, and all lot of steps. It is not. It will be an organization, so it's not easy to buy anyone. If it is an individual, yeah, that he can also arrange something and buy tomorrow, but it is not that much easy for an organization to procure all those infrastructure and provision and all, right? So that's why we discussed on the previous session this virtualized deployment became popular. Here what happened? Here it is like either we have a hardware or VM, hardware, VM or something. So here what happened? We will have an operating system. I will define it as an OS. And with the help of a virtualization software, which means a hypervisor or something, what we will do? We will have different
Containers.
Yeah, different machines that we can create now. Different machines that we can create. Let's say VM, VM. Okay, different machines we create, and in that we will have an OS. We will have an OS. Also, there will be binaries or something related to that, and we may have an application installed in it. Similarly for all. So that then it is like we have a virtualized and deployment, so that here what happens is a virtualization when this virtualization one introduced actually, but the main advantage is it allows us to run multiple VMs, right? Because in one VM, with the use of a hypervisor or virtualization software, we can run different VM in a single server.
Single server.
Yeah, so then it will allow us to isolate the applications in between VMs. So what happens here? We have app. Here we will have another application. Here we will have another application. Maybe here we have two applications. So the applications will be isolated between VMs, right? So this will be isolated like this. In between VM kind of isolations will be happen. So this will be isolated. This will be isolated like that. So isolation happens across VMs actually. And so it will provide a level of security, right? Because one application cannot go to the other application and access other details and all. So it kind of level of security will also be applied over there. So here we will get that we faced some utilization of resources and all in physical server now. So that case will be eliminated, and it will help us to allow some scalability and all in terms of that application, because we can add or update it is easily because there are different VMs, so that we can handle it easily. So it will also reduce some cost because we don't need to buy a new hardware or VM or something like that as frequent as traditional deployment demands. But we need to an extent, but yeah, to an extent it should be fine. So with the help of this virtualization, we can represent a physical, like it is like VMs will be allocated and applications will be consuming those VMs resources only. So they can't go into the next VM and they don't need to consume the other details. So isolations will be happened and the resource allocation will be taken care. So yeah, to an extent, all issues are addressed. And yeah, once virtualization deployment is happened, then this containerization deployment comes in. Okay. So here what happens, it is like similarly the same kind of thing, but we will have an underlying infrastructure, hardware or VM. And what happens, we have an operating system available over here, and what we will have a runtime, means Docker engine, or similarly, for example, we have a Docker engine, or we may have a container runtime, some kind of setup to enable containers. So then here what we can do, we may have multiple containers in place. So app we can easily deploy. So all of these are containers. Okay. So here what is advantage that we have? These containers, yeah, 1, 2, 3, 5, 6. Okay, all of them, these are containers actually. Yes, you know, we just discussed it in the last class actually. So these containers are nothing but VMs. We can call it as lightweight VMs. Lightweight in the sense it will have that kind of, like, similar to VM, such as a container have its own file system, CPU, memory, all those things it will have. But it is like a lightweight. You can consider it a lightweight, not much as heavy as a VM, but it is a mini VM, we can call it at that. Okay. So the main thing is, this is not much dependent on the hardware and OS. So we can easily, it will be portable as expected, and we can go for further deployments and all. Okay. So once this is happened, okay, this will help in different areas actually, which means it will help us in creation and deployment. Okay. It will help us. How it will help us? It will increase the efficiency. Okay, increase the efficiency of the creation or creation of an image, for example, Docker image, rather than creating a VM. Okay, so it will give more efficiency. It will be easy to create an image rather than a VM and deploy. Okay, and it will support development, integration. It will support development, integration, as well as deployment, which means it will provide a reliable way and a frequent way that we can build images, because we can continuously build images and we can deploy within no time. No time means very fast, very quick. We can deploy, and if we need to like destroy that, that's also possible. So it will help us to efficiently manage all these tasks. And yeah, definitely it also help us to segregate or separate, we can mention, because in Docker images, what we are doing, like we are creating a Docker file with the help of, we are creating image, and then from there we are creating containers. So building images, then creating containers. So it is like, first we will have an image in place, then we will have a container. So once we are building it, then we are running it, which means there is no direct impact on running, correct? Because we have an image in place. Once we have that image, then we will run and this will work. So it will be helpful in terms of deployment, because this is the action where deployment is happening, correct? Whenever we are running that Docker image, that container is creating, that time deployment is happening. Here image creation is happening. So it will not affect the deployment time. So because it is not much depending upon the underlying infrastructure. And there is another thing, observability. Okay, this is a huge topic, but yeah, observability means it will give us a lot of information in terms of metrics or traces or logs and all. So we can observe these deployments, its health, other signals and all, with the help of these kind of metrics and all. Yeah, there are a lot of tools that we are using to observe all this infrastructure, but we will be able to do that. Okay. And okay. Yeah, next is like this separation. Separation means environmental kind of separation. Okay, environmental separation. That means, yeah, I said no, we will have a different variations of environments like development, testing environment, product, prod. Do you remember that?
Yeah, those are the phases of environment.
Different versions of our application, where
production.
most of the developers will work on the development side. Then the testers will work on the testing side. Then from there, we will get a version of our good product. Then once pre-prod is fine, we will go with the production, and this will be the customer facing application. So there may be pre-prod or like sometimes there will be pre-prod or there will not be. It's according to the complaints of that organization. But the idea is developers will be working on development, UAT testing guys will be working on UAT, and this will be the public facing application production. So
Yes, sir.
yeah, and yeah, that is very portable. Portable in the sense we can deploy it in different cloud or in our laptop on premises, wherever we can deploy these containers. Okay, you don't need to like take a cloud and provision a VM and go install all these things inside that VM and all. We can do it in your system, but it's like why we are taking that is to manage it easily, because once we created it and all, then we can delete it. So that's is done. So as part of lab, we can do it like that, practice like that, but it is possible in our laptop itself.
Okay.
Yeah. So basically, that is the main advantage or main advantage of this cloud container deployment, and it will help us in different verticals. So in terms of resource isolation, as we said, no, that's also be happened easily, and also that utilization it can be take care, like it will be highly efficiently, and it can be taken care about that efficiency in terms of utilization of the resource. So if we are isolating those applications as well, we can expect or we can predict the application's performance as well, because even if an application is going up and it is taking too much resource utilization and all, there will not be any issues, because the other application is in another container which is completely isolated from the first one. So there will not be that kind of scenarios as well.
Okay. But let's say, sir, if let's say like in this combination deployment section in application one, let's say if it's taking like a 100 gigabytes of something storage or something, and in future like um, the storage like hit up and we need to like increase the storage or increase the capacity of that, so can we deal with that?
Yeah, like scaling up or upgrading or scaling up, down. Yeah, everything can be done. Yeah.
Because in the virtual deployment,
in virtualized deployment, what happens is, yeah, we can do that to an extent. We can do that.
Yes.
The main issue is like the resource, like we need to procure something exactly new is in that kind of limitation we will be mainly facing on traditional deployment, because here we need to buy some infrastructure and all. Mainly here the issue is like what we will be having, some kind of what we will have some, we can isolate it, but considering containerization, it will be more better than this, right? Because we don't need to rely on a VM and all. It will be like completely the container runtime or the engine that we will be deploying. So it will be a container itself. So we can call it as a lightweight VM.
Okay. So Docker itself is an independent. I mean, it's not dependent on the virtual deployment.
Yeah, Docker or like the container runtime. Here we can the runtime that they are getting. Okay, so either it will be the Docker engine, or maybe it will be giving like getting a container runtime over here. So some kind of container runtime, which means they need something that helps to run a container. That's it. Either it may be Docker, or there are different kind of container runtimes available. So it's like that, the technology.
Yes.
So, and yeah, there are a lot of things. Means containerize is it's a good way to bundle our applications, because in production environment we need to manage some containers that run application and ensure no time. So what happens? We can do some, if a container is going down, another container comes in, it will start. So it is not easy to handle it by what? By manually, right? Because we don't know when one container will goes down. So there will be some kind of configurations in the Kubernetes to handle all these situations. So Kubernetes will provide you some kind of framework to run all these distributed systems resiliently. Resiliently means it will be like taken care of as per the requirement, as per the situation. So scaling up, or if something failover happened, means something happened and the failover has to be taken care, or maybe we need to like upgrade, that kind of things. All of these things can be taken care of Kubernetes. So it will be like there are a lot of internal things happening inside. We can associate storage, we can automate, like we can mention how many copies of these containers has to be run. So there are a lot of things that we can mention in that containers. Okay, so that's the basic idea of this Kubernetes, and I'll explain one more concept in the sense, yeah, and yeah, definitely there is Azure Kubernetes service that we will be mainly discussing on. So on that topic, we have different kind of Kubernetes. Okay, so Kubernetes, or the K8s we will call. So there are managed Kubernetes. So managed Kubernetes means which is a service that provided by most of the cloud providers, AWS or Azure or GCP. Okay, they are providing their solutions. Azure is providing AKS, Azure Kubernetes Service. GCP is providing GKE, Google Compute Engine. Sorry, Google Kubernetes Engine. AWS is providing EKS, Elastic Kubernetes Service. So everything is similar. Mainly there are, I'll give you a simple idea. There are two components, okay? Two components. We can classify as high level. In a high level view, we can classify as a two components. One is, we can call it as control plane, or the master node we can call. This is the worker node. Okay. So the thing is, it will be working in a master slave kind of principle. Okay. So here we will have multiple VMs, and there are four components here we have. Okay. One database will be here. One kind of scheduler will be here. One kind of server will be there. Like that. I'll explain that. But there will be two components, like mainly in high level, there will be two components. And in normal cases, what it is, we need to manage these two components. Okay. either the worker area as well as the control area, we need to control. Okay. But in managed Kubernetes, which is like either EKS, AKS, or GKE, what happens is this part will be, the control plane will be taken care by the respective cloud provider, which means if it is an AKS, this will be taken care of Azure. So we don't need to think about it. We only need to manage these VMs. Okay, VMs in the sense I'm calling it lightweight VMs. Do you get a high level idea?
Okay, so it means the managed Kubernetes will be taken care by the Azure itself.
Yeah, AKS is a managed Kubernetes. Okay. Examples of managed Kubernetes are AKS, EKS, and GKE. So if it is a managed Kubernetes, then the control plane, this control area will be taken care by the respective cloud provider. If it is AKS, then it will be taken care by Azure. If it is EKS, it will be taken care by AWS. If it is GKE, it will be taken care by GCP. We only need to worry about this worker node. Okay, we may have different VMs, lightweight VMs available here, so that we need to manage. But in normal, if we can say as normal Kubernetes, it is not managed. Then we need to take control of control plane as well as worker node. Got it?
Yes, I got it.
That's like perfect.
Yes, sir.
Okay, let me open another screen now.
But sir, for the most of the time, which Kubernetes would be? I mean, would us be using like the normal Kubernetes or the second one, like the managed Kubernetes and the other Kubernetes? I mean, which Kubernetes are we working on for the most time?
Yeah, mostly if it is in cloud, it will be managed Kubernetes. If it is in on-prem or something, then mostly we will get normal Kubernetes. So mostly in cloud and yeah, it will be mostly managed Kubernetes.
Okay.
Because the overhead of that control plane will be taken care by the provider, no? So if we need, like if we are thinking or if there is a requirement to manage that control plane within our hands, either as part of some requirement or something, then only we need to go with normal Kubernetes. Otherwise, mostly either managed Kubernetes could be found.
Okay.
Okay, so here I'm going to discuss one more thing, which will be helpful for you. Why this architecture kind of thing is needed. Okay, so when it comes to software architecture, okay, software architecture, there are different ways of approaching it. mainly how this software is architectured, which means how they are planning or how they are constructed. So in terms of that, we have mainly monolithic, okay, monolith. We will call it as monolithic concept architecture. And there is one another called microservices. Yeah, that we will discuss. But monolithic architecture is something like it is single, as we know, single. Now, mono is single now. So it will be a single code base. It will be working on a single code base, which means either it is a Python or Java or whatever, C# or whatever that they are, PHP, either. So it will be on a single code base. Okay. And it will have all the programs components, which means including backend, front end, and also the configurations. So I'm saying about the configurations of application, sorry, architecture of the software. So it will have a single component, okay, which includes backend, front end, as well as the configuration. So all these things will be tightly coupled and it will be act as one. Okay. So why it is like, it is very easy. It is easy to design, easy to deploy, easy to do things. Okay. So the main is the advantage is like yeah, I'll bring you a picture so that you can understand it a little bit better. See here, monolith, what happens? All things are in one server, tightly coupled. Front end, login, data access, user management, invoice, everything is there in there, and it is storing in data store. Okay, this is what is, I said no, monolithic. Okay, so what are the main advantages of this? It is very easy to create and deploy. Okay, so the first one is like, it is very easy to, easy to create and deploy. Okay.
Yeah, because the work would be managed by different.
Yeah, because it is in a single structure, so it is easy to handle. Also easy to test, because it is, if the test is going good, then it is easy to test actually. Only we don't need to rely on more skills. Only few skill sets is needed. How you need to do a backend, front end configure, then you can do this. Also, we can, in terms of security also, it's easy to handle because only one thing is now. So we can easily handle, security as well. Okay. But here, what happens is, this will be the, we can call it as pros. Okay. And let's consider some scenarios, like let's discuss out the cons. So main thing is complexity in maintenance. Okay. Because if we need to add something over here, this are like in login, what happens is the entire application goes down. We need to update it, and then it's come up. Okay. So if we add another component here, all times we need to do like that. And if we are thinking to add something sub, okay, all these times we need to redo this, like the applications will go down and do this. And it is very hard to integrate all this, because if it is going larger or as a submodule or something, it will be very harder to complex to maintenance actually. So as I said, it is very hard to change the infrastructure that we have, because we need to update everything in it. Maybe we reference something over here or here, everything we need to update. So changes is little bit difficult. Also scaling, which means if we need to, as I said, no, if we need to scale this module to a bigger audience or bigger area or in a wide range, the scope we need to increase, then it will be a difficult task, or it will be costly as well. And if any of this front-end login or any of these things is going to fail, then the entire application will go fail. So we can say that it will be having a single point of failure, because if anything is failed, then what happens? The application will go down. So this will be the main issue. Okay, when we consider about a monolithic. So that's why micro services architecture comes in. Okay. In microservices, what happens is it breaks down the system components into distinct pieces. Okay. So that can be created or implemented. We can scale it independently. So the thing is, we can that it is breakdowns into system components. Like here, if it is like this, we may have front end available. Yeah, I'll give you another picture so that you'll get that idea. See here what happened. We have different now. We have a shipping service. We have an inventory service, account service. Everything is connected to its own DB. So what happens? It should be like even shipping service is not down, like the others will work. So what happens is it is breakdown into single services. If it is like this, it is very easy to build. If we need to update this account service, we only need to configure something in accounts. Or if we need to upgrade or something in shipping service, we can do it right away. Or we need to do it in store web app, this we can do. Like it will be different modules. So we can easily manage this in terms of upgrade and all. We can easily manage. Okay, so everything should be self-contained. These modules could be what? Self-contained. So it will have, they can be debugged or they can be deployed or they can be managed in easily without disturbing the other module, which means it will be what? Will be in independently working. Okay. Also, yeah, if it is, as we said, it is independent, it is very easy to scale. Okay. And more adaptively, we can, it is adaptable to new functionalities. So we can say that it is more adaptable. Okay. So these are the advantages. Okay. And it is like, these are the two kind of architecture that we have in software. So either will be relying on monolithic or microservices. It is not recommended to go with microservices all the time. Okay. And it is not recommended to go with monolithic all the time. It is like the requirement that we are getting. So maybe it is a simple application which is not expanding in nearby future or a foreseeable future. Then it's fine to have monolithic because it is easy to deploy, easy to handle. Like there are a lot of things that, right? But if it is something like, for example, a Flipkart or an Amazon, we have login, we have cart, we have dashboard, we have home page, we have product page, we have payment page, support page, right? There are a lot of pages, right? So
Yes, sir.
all these pages are created as a microservice, which means even if the payment gateway fails or payment module fails, we can search for the contents. We can search, browse the items that we have. We can go to the cart. We can add the details, add like items to the cart. We can remove the items from the cart. Even if what payment is failing, right?
Yeah, yes, sir. Also,
Yeah,
we have
because
like different teams managing the
yeah,
different stuff.
it is kind of microservice architecture. Okay, here you can see, shipping service, inventory service, account service, lot of different kind of service, no? So everything is independently handling. So even if login, like in Flipkart or Amazon, login is not much needed, right? Maybe we can purchase it with us without a login as well, correct? So if the login is not working, we can browse the items, we can see the items, we can add to the carts, we can directly check out, but the login is not happening. But we are not visiting to the login page itself. But let's say payment gateway is down. Login is working, everything is working. We can go play around with that. If we need to pay, then the payment has to work. Otherwise, system will be up, but payment will be gateway will be down. So that is the concept of microservices. Okay, do you get the differences?
Yes, sir. I mean, microservices is totally seems to be online thing, the web thing, but I mean, comparatively with the monolithic
Yeah,
thing.
it is like less dependent on the services it will have, but it is mainly like it is capable of the modules that they will have will be capable of handling requests independently. Yeah, this is another kind of representation in monolithic architecture. We will have a single database, so business logics, everything will be like in sync in a single way. But here what happens? Microservices, we have user interface. There are different kind of microservices and different kind of database, so that even if anyone goes down, it will not affect the entire application. Okay.
Yes, sir.
We can consider this as like monolithic as a car or something, because if something goes down, it will not work. Okay. Something like that. So it's like independent, and the idea, you got the idea now. So you need to understand it, what it is microservice architecture, because in interviews or sometimes you will get those questions, what is the microservice architecture? So mainly the answer is like, it is like handling services independently. You can give some example like a Flipkart or something, so that there are a lot of modules. Either one of the module is not working, the other module will be working. You will be able to access it. But in monolithic, what happens is if any modules goes down, the entire application goes down, because it will only have one database to store. and everything is tightly coupled. Here it is loosely coupled, that is independent, like that.
Okay, sir.
Okay, so and you may get a questions like, it is recommended to use microservices for all? Actually, the answer is no, because we need to understand the goals, we need to understand the requirement, then only we can suggest. If it is a simple thing, we can go for monolithic. We don't need to rely on microservices. If it is a big thing, or which is expanding day by day, or in near future, or in a foreseeable future, then we can go with microservice architecture.
Exactly, sir. Like example for the Amazon, like when it was new to the market, I guess it was totally on the monolithic thing. But
Yeah,
later on,
definitely.
it switched to
Then slowly,
microservice.
yeah. But see, if they have they are planning to bringing the Amazon as like the whatever the components that we have currently, no. If they are bringing that thing to be introduced initially, okay, they are thinking to introduce this the entire setup currently what it is Amazon having. They are trying to introduce it to the world, and if they are following monolithic, it will be huge headache, no?
Yes, sir. Definitely, it will be a
Yeah.
headache.
So, but for example, I have a website, okay, a home page, a profile, a about us page, okay. Then I don't need to go to microservices, because what, it is like a simple one. I don't need to create multiple services and handle multiple databases and a lot of things. I don't need to, because it will be definitely, it will be a what we need more technology experts, we need technical experts to handle all those things, right? But here in monolithics, we don't need much technical stack, so that we can also easily handle that. So it's like that according to the requirement. So why
Yes, sir.
I
Exactly.
covered this area is this microservice architecture can be achieved with the help of containers and all. Yeah, we can also rely on VMs as well, but it can be morely mainly adaptable with the help of containers. So Kubernetes,
Yeah,
something or containers and all, because we will have small VMs now, so that we
yeah.
can handle. Either if it
We can
is,
specify.
yeah,
Yeah, we can specify each services with each container.
yeah, we can go create separate containers for separate services, and we can do that. Either it is
Yes.
possible with VMs as well. Also, for example, if we have a VNet, in that VNet, okay, we have a VNet. Yeah, I can explain. We have a VNet. We have and we have 3 subnets. Okay, and databases will be here. Server will be here. That traffic presentation kind of thing means, let's say traffic. Okay, traffic will be here. So we can establish connection like if it is in a VNet, they can talk to each other. So it will be connected. So we can call it as this is a module, like this is a 3-tier architecture. Okay, 3-tier architecture. And we can mention, yeah, in the server we will have like server subnet, we have different VMs available which serves different services, but which is not needed now, because to serve a single service, it's very like unethical to provision a VM. But if it is a container, that's fine. So
Yeah.
that's how we can manage. Yeah. So it's like the concepts of this Kubernetes and all, and yeah, mainly I'll be sharing this documentation Yeah, similarly, you can you will have that repo that I have shared. No, I shared one Git repo over in our chat. Yeah, I'll be updating these contents in that so that you can check in and just learn from that. Also, you will get a case how like you will get just an idea. Just an idea means, yeah, I'll give you that picture also. So I said no here where I said okay. Yeah, here I said no, we have the control plane. See, this will be managed by AKS. So see, the control plane will be managed by the AKS and Parker node means lot of VMs. Means ports, or we can call it as, yeah, I will come to ports later, but you can Docker, you know, right? So ports are kind of smallest unit of a Kubernetes. Okay, just remember that for now. Ports are the smallest deployable unit. Okay, we can deploy port.
Okay.
Port will be the smallest unit of a container Kubernetes, and this control plane will be taken care by Azure. And using this file, one YAML file, we can
Create Kubernetes.
yeah, manage. We can create containers. Okay. So and the further session we will discuss further topics and the lab in the next session. And let's see, let's catch up on the next session. Okay. So do you have any questions? Good to go now.
No, as of now, no questions, sir. So,
Okay.
so basically, for the Docker thing, that I mean, the procedure which we have followed, like we have created a virtual machine, and then in that virtual machine we have installed the Docker and all. So
Yeah.
instead of that Docker, we are going to install the Kubernetes, right?
Yeah, we don't need to install Kubernetes.
Okay.
Actually, yeah, here we have Azure AKS, no? So we will be provisioning Kubernetes service in our cloud, and we will be consuming that. Okay.
Okay. Okay.
Okay.
It's already there. Just we are
Yeah, we
taking
need
into
to
use
connect
that.
to that, and we need to manage our deployments, right? Like that.
Okay. Yeah, because for the Docker, we were installing the Docker and all.
It is like, yeah. So it is something like we need a runtime to run some containers. That's it. So if we have a Docker in place, yeah, like we need a Docker, but like it's upon us, because you see here we have Docker, no? Docker, see Docker.
Yes, sir.
You can see, no?
Yes.
Yeah. Okay. Yeah, we'll clarify it in the hands-on labs that we will have in the next session.
Okay, sir. Definitely.
Okay, cool. Yeah, then that's it. That's for today. Thanks for joining.